Assalamu alaikum. The class today is actually for the revision. We have a paper tomorrow. So we are making this quick revision. The main idea is to revise important chapter. The main idea is to revise main concepts in every chapter. And when you have a paper four has two main issues. It's a very long paper. It's a 2-hour paper. Secondly, when you write Secondly, when you write, when you write answers in paper 4, you are always considered to be your language. You have to improve the answer quality of language because it's a memory-based work. I'm starting with circular motion, and it's a type of interactive class. You can always answer on the mic, and because writing theory on a chat is always difficult, but you can write. I'm starting with circular motion. What are the main concepts of circular motion? The main concepts of circular motion, if I start from the title, that there are some important terminologies like omega, like theta, like t, time period, and frequency. Omega is the angular velocity, theta is the angular displacement, and t is the time period. We have a very important formula. T is equal to 2 pi upon omega. And similarly, F is equal to omega upon 2 pi. As it is a slow pace revision, and you people can also write with me, it's not a type of digital response, so you can also copy with me, and this will be a type of revision. Remember that in every chapter A2 physics, every chapter, there are not so many concepts. This is something good about A2 physics. There is always some limited concepts in every chapter, limited important concepts. There are many formulas, that is right. Second concept is the contrast between V and omega. We have a formula, V is equal to omega R. What is omega? Omega is basically angular velocity. Omega is angular velocity, and it is measured in radian per second. So these are the initial important concepts of circular motion. I move forward, and I put the third concept in this chapter. The third concept is centripetal acceleration. When an object is moving in a circle, the acceleration is always directed towards the center. So in a circular motion, the centripetal acceleration is A is equal to omega square R, and A is equal to V square upon R. As I have already mentioned, that you people should be writing with me. This is the best way to revise anything in sciences. So if you write and you keep on writing and remembering, you can eventually remember it. I have started my revision with circular motion. This is a very fundamental chapter. It doesn't come as a whole question. Circular motion and gravitation, they come together. After centripetal acceleration, my next title concept is centripetal force. The concept says that circular motion is not a natural motion. You have to apply a force. So in a circular motion, the resultant force must be directed towards the center of the circle. So in other words, when an object is moving in a circle, we have to force the object. We have to force the object to stay in circle. This is a requirement. So the object cannot escape. This is this force, which is called centripetal force, center directed force. So I repeat the concept. Circular motion, a circular motion is a periodic motion, and it is not natural. You have to apply a force. In a circular motion, the force is always directed towards the center, the resultant force. So in every circular motion, there is a resultant force which has to be directed towards the center. I recall the formula: F is equal to mv square upon r, and F is equal to mr omega square. So this is the chapter circular motion, which is not giving a separate question every time. It is a part of gravitation. I move to my second chapter for the midterm syllabus, and that is gravitation. I'm starting with the fundamental concept, that is the Newton law of gravitation. The chapter first concept, which is the main concept of this chapter, is Newton's law. Newton's law says that the force of attraction, this is the case of two masses, two isolated masses. Newton's law says that the force of attraction between two masses is directly proportional to the product of the masses and inversely proportional to the square of the separation between the masses. So Newton's law of gravitation can be given F is equal to G m1 m2 upon r square. This is called Newton's law of gravitation, and Newton says that the force of attraction is the only force. Masses cannot repel each other. Now, as we move in this chapter, the next concept, which is the core concept, is gravitational. We are just revising the core concept. Gravitational field strength. Its symbol is G. It is the force per unit mass. It is just like the signal strength. So when you take a mobile and you check the signal in a particular area and you call it signal strength. So signal strength is like here, and it is the gravitational signal strength. After this one, the all-time famous gravitational potential. It's a very important concept. It appears repeatedly in our course. It is 5. What is gravitational potential? This is a central mass, and mass is here at infinity, and it is moving from infinity. So when a point mass is moving from infinity to a central mass, you need to do some work. This work done per unit mass is called gravitational potential. Its unit is joule per kg. So what is gravitational potential? It is the work done per unit mass to move it from infinity to that particular point. Remember, a very famous concept, that gravitational potential is always negative. So as I said, this is a type of manual revision. Definitely, I have shared with you people multiple files. The digital files are there, And what I always tell, which I always repeat in my classes, that you have to write. This is the best way of revision, and digital video files are there for the midterm tomorrow. How you should be preparing for the past paper questions, that when the paper is tomorrow, so you should revise the theory. And if you have done already some papers, then you should just try some new papers like 2021, 2022, 2023, 2020. Just like take one paper. There are many papers, right? February, March, and then May, June, and then October, November. So there are 3 sessions every year. So just take any 1 or 2 papers and do the corresponding questions. So it will be a flipping experience, and you will be doing questions back to back. It will be an excellent way of revising, but first revise the theory. So just like if you have a paper next day, you should revise the whole theory. We have notes. I have 2 options always. One is the physical notes, which I have we have made written in the class. Second is the digital notes. Which I have shared for every chapter. So I continue my gravitation title. The next important concept, which is in terms of derivation, is always there. Kepler's third law. Kepler's third law says that T square is proportional to R cube. The formula can also be written as T1 upon T2 square R1 upon R2 ka whole cube. Kepler's law says that the gravitational force provides centripetal force for every object when you move in space. So if gravitational force is G_mm upon R square, it is equal to mr omega square. Or if G_mm upon R square, it is equal to mv square upon R. This is a type of the most important derivation of this chapter. And the people who have done past paper, they know that this derivation comes very oftenly. Then I move to the next concept of this heavyweight chapter, that is U, which is gravitational potential energy. The concept is there that every object is bound to stay in our gravitational field. So nothing can escape. Why nothing can escape itself? Because the gravitational potential energy is holding it. That is why gravitational potential energy is always negative for any mass. It is like this. Gravitational potential energy is always negative. Gravitational potential energy is always negative. So I move to my next topic. I move to my next chapter of my syllabus. That is electric field. Electric field, this chapter is a convert chapter. There are 2 versions of this chapter, AS and A2. And you people should revise both the versions. I have made notes for both of them. If I start with the AS version, you have to revise. The main concept is electric field strength. It is F upon Q. What is the formula for electric field strength? It is force upon charge. And how we define it, electric field strength, it is the force per unit charge. This is an important formula. Then delta W is equal to Q delta V. When a charged particle is moving, in an electric field, it does some work. And this is the work done, which can be converted into its potential energy. And we had a formula E is equal to V upon D. This is the AS version of electric field. As I already had mentioned, that how you people should be preparing for tomorrow. As I have written on the group also, that revise the theory. You have notes. Digital notes are also available, and printed notes are also available. So if you revise from the main notes, that will be the best if you revise everything. But if you want to revise from the digital notes, I have provided them on the group. They are chapter-wise notes. Now, the A2 version of this chapter start with a very important law, Coulomb's law. What Coulomb law says that there are two charges, suppose both are positive. Coulomb law says that the force of repulsion, like this is repulsion, the force of repulsion or attraction between two charges is directly proportional to the charges and inversely proportional to the square of the charges. Here you can write K Q1 Q2 upon R square. While what was K? K was 1 upon 4 pi epsilon naught. This is Coulomb's law. This is the main topic in electric field, one of the most repeating topic. Coulomb law says that the force of attraction or repulsion between two charges is always proportional to the product of the charges. Then, if we move forward, we have the formula for electric field strength, that is K Q upon R square. This is the formula for electric field strength. And when you say electric field strength, this will be the third formula. Then we talk about electric potential. Electric potential. So we have a positive charge here and we have a positive charge here, and it's moving towards the bigger charge. It is at infinity. It has to reach here, this position P. Same as gravitational potential. It is the work done. It is the work done per unit charge. It is the work done per unit charge to move it from infinity to a particular point. So it is V is equal to W upon Q. This is gravitational potential. Now remember that gravitational potential V can be positive and it can also be negative. So electric potential is basically a concept of work done. It is just like the concept of gravitational potential. Then a very important concept which comes very oftenly in the paper, that you have a sphere. And suppose the sphere is positively charged like this. The sphere is positively charged. And at the center of the sphere, you have placed a positive charge. Now the charged particle is moving like this. This is the radius of the sphere. Now there are two important sketches when the sphere is moving, when the small charge is moving. One is electric field against the distance, and in this case the electric field is 0 in the center, and then it increases and then decreases. While the second graph is voltage against X, it first remains constant. This is a graph which has appeared in the paper many times. I move forward to my next chapter, that is in our course, capacitor. Capacitor, this is the symbol. Capacitor is a circuit component which stores electrical energy. It doesn't store electrical charge because the resultant charge is zero, but capacitor is actually designed to store electric potential energy. Capacitor is designed to store electrical potential energy. When you connect capacitor in a circuit, one of the plate of the capacitor stores positive charge. So suppose I connect it in a circuit and then I have positive, negative voltage switch. This will be positive, this will be negative. Now, when we switch on the circuit like capacitor here, when we switch on the circuit, we need to separate these charges. So we need to keep them separate. So for this separation, we need to do some work. For this separation, we need to do some work. This work done is stored in capacitor as electric potential energy. This is the main purpose of a capacitor. So capacitors are designed to store electrical energy, and this is for keeping the charges separate from each other. Then comes the main formula that when you are charging a capacitor, the charge is proportional to voltage. This is the main formula, main sketch of capacitor. This is one. And Q is equal to CV. There comes the very famous definition from this chapter. What is C? C up is equal to Q upon V, and it is called as capacitance, and its unit is farad. Capacitance is the charge stored per unit voltage. Now, when you draw this graph, you get the area here like this, and this area shows the work done by the capacitor. So if you find the area here, area is equal to half QV. This area shows the work done or the energy storage. Same formula can be written as half CV square. So capacitors are designed to store electrical energy. 2022, they introduced a topic which is now coming regularly, that is the time constant. Tau is equal to CR. And then X is equal to X naught e power minus KX. Any letter can be used. And then you can use minus T upon CR. So this formula is used. This formula is used for discharge of a capacitor. This is a very important formula. And in all the new papers after 2022, all new papers, this is coming. I hope people remember that what this tau stands for. The tau stands for time constant. Exponential formulas, whenever you are dealing with exponential formulas, you should remember that it is a function of ln. So if you are not a math student, you should remember that it is ln x upon x naught is equal to minus t upon cr. Normally, when people do the past papers, they overlook this formula. This formula in all the new papers is very important, because remember that it is a new topic, and this formula, because normally people do not do the latest paper, I have advised you people that revise the course. As I'm revising with you, revise the course. There are two options: either revise from our classwork notes which are in detail notes. Second option, I have posted chapter wise notes, a folder which contain chapter wise notes. You can do that also, and that will give you a quick revision. Then you people should take any new paper, 2020, 21, or 22, or 23. Take any new paper and do the questions which are corresponding. So it's just like doing a paper questions. This will help you to manage the flipping. The topics will change. So I move forward to my next chapter. After capacitor, the next chapter is the biggest chapter in our course, that is magnetic field. Magnetic field is a heavyweight chapter, and it comes every year. And in the actual paper, it is the only chapter which can even give two questions. Normally, chapters are not that much big. Magnetic field, if I start with the definition, it is a field. It's a field due to moving charges. Magnetic field is a field due to moving charges. Then chapter puts the first formula for magnetic field. B is equal to phi upon A, phi upon area. What is phi? Phi is the flux linkage. So when you draw a magnetic field, you suppose put a sheet here and you draw magnetic field, and suppose these are the field lines which are passing through this material. So some lines are passing through this material. Some lines are passing through this material like this. These are the field lines. Now, what is flux? Flux is the, what is phi? Phi is the flux linkage. So this phi is the flux linkage. So this is the first formula. If you rearrange this formula, phi is equal to BA, sorry. And if you introduce the number of turns, the formula becomes NBA. If you further introduce the angle, then the formula becomes NBA sine theta. So this is the first main formula of this chapter. Phi is equal to NBA, where N stands for number of turns. As the chapter proceeds forward, it gives the concept, if you people remember, that after establishing what is a magnetic field, then we have a concept of solenoid. We have a concept of solenoid, and we have a concept of circular coil. Circular coil is like a loop, and it is a bent loop. Then chapter puts next concept, which is very important. Chapter puts the next concept, that is the wires. Two wires are having currents in the same direction. They will attract each other. two wires having current in opposite direction, they will repel each other. We have a secondary concept here, which is also very important, that when a wire is straight, magnetic field is circular. Separation between the circles increases, and this is the place where you introduce Fleming's right hand rule. We introduce Fleming's right hand rule. We also have a concept of dot and cross. Dot means out of the page and cross means in the page. So like currents attract each other and unlike currents repel each other. Now, if we move forward and we reach here, after doing this point, a very, very important concept comes that if you have a magnetic field like this, and you put a wire in the magnetic field, and the wire produces magnetic field around it. Now, what will be the response of your resident magnetic field? The resident magnetic field will be stretched out, and this is basically a concept of a force on the wire. The wire will experience a force. This force is actually a type of restoring force. So what was the concept? When a current carrying conductor is placed in a magnetic field, it experiences a force. This force will try to remove the wire from the field. We determine this force by all-time famous Fleming's left-hand rule. I have shared one or two videos also for this. Fleming's left-hand rule is used to determine the direction of the force on a wire. Fleming's left-hand rule is also applied to a very important situation, which now I am discussing, that suppose this is a magnetic field. This is a magnetic field directed in the page. Now, suppose the charged particles are coming from here. This is an electron, so the current will be in the backward direction. When the charged particle enters the field, it will bend like this because the force on the charged particle is centripetal in nature. So when a charged particle enters in a magnetic field, it experiences a force which gives a centripetal effect. Now, there are two important formulas of this force. F is equal to BIL sine theta, where theta is normally 90 degree. Then QVB sine theta. So these are the two important formulas. The two formulas can also be used to define the define B, magnetic field strength. The unit of B, which should always be remembered, is Tesla. Now, if we move forward in this chapter, we then get a very important topic, which is the most repeating in the new paper, is the Hall effect. What is Hall effect? You have a conductor, you have a flat conductor like this, and you put it in a magnetic field, like this is a magnetic field. You put it in a magnetic field, and suppose you put a wire, and this is a beam of electrons. So you send electrons in the metal sheet like an aluminum foil. Magnetic field forces the electrons to bend downward. When electrons bend downward, they will produce a negative charge on the lower plate. This will induce a positive charge on the top plate. Now, after some time, the new electrons will begin to get a upward force, because now there is an electric field across the conductor. Now they will experience an upward force against the downward force. This later develop a potential difference or voltage across the plate. This is called Hall effect. It is basically an effect of voltage across a conductor which is placed in a magnetic field. It's a flat conductor. So after some time, what will happen? After some time, this conductor is there. After some time, the electrons begin to move in a straight line because the upward force balances the downward force. So the electric force balances the magnetic force. And that is to say, QE is equal to QVB. This is the approach. This is called Hall effect. The famous device which works on the principle of Hall effect, the all-time famous device is Hall effect is Hall probe. Hall probe is an apparatus to detect magnetic field. Hall probe is used to detect magnetic field in a region. You can use it to define or detect magnetic field. Now, I move to my next chapter. Magnetic field is there. My next chapter is electromagnetic induction. In the past paper, electromagnetic induction is not coming as a separate chapter like circular motion. It is not a separate chapter. Normally, it comes with the magnetic field. So it is a co-chapter. It is a connected chapter. The first concept, let's put the first concept. You can convert mechanical energy. You can convert mechanical energy into electrical energy in presence of a magnetic field. So what is electromagnetic induction? Electromagnetic induction is a concept of generating. It's a concept of generating electricity. So it is a contrast with electromagnetism. Electromagnetism deals with current to magnetism, and electromagnetic induction, it deals with magnetism to current. The dominating are two laws. One is called Faraday law. This is a very dominating law of this chapter. The chapter orbits it. Faraday law says that induced EMF, if you write it like this, induced EMF is directly proportional to the rate of change of flux. So we have a formula, E is equal to minus N phi upon T. This is called Faraday law. There is a negative sign. Why there is a negative sign? This is according to Lenz's law. Now, how this Faraday law works? Faraday law says that when there is a Faraday law says that when there is a relative motion between a conductor and a magnetic field, you will get an induced voltage. Suppose this is their favorite diagram, and I am moving the conductor towards the solenoid. This is a magnetic field pattern. Now, as the conductor approaches the solenoid, the field lines will be cutting through the solenoid. This will induce an EMF and the needle vibrates. If the bar magnet is moving, magnetic field will induce voltage, but if it is not moving, the magnetic field will not able to generate any current. The corresponding law here, which is the sister topic here, is the Lenz's law. What Lenz's law says? Lenz law says that whatever you are doing to generate electricity, you will get an opposition. It is just like driving on a road and your car faces some friction, which is natural, which has to be there. Similarly, when you generate electricity and you are cutting the field lines, you will get an EMF, and EMF will eventually get an opposition. How this happens? For example, in the above bar magnet, when the bar magnet approaches, you will see that the solenoid will generate a south pole here and a north pole here. If you are bringing it here, it will generate a south to repel it. So Lenz's law says that the induced EMF always opposes the source producing it. Induced EMF says that the source which is producing it will be always opposing it. It's like a self-opposition, and Lenz's law is a consequence of law of conservation of energy. Lenz's law is a consequence of the law of conservation of energy. This is the topic which is actually an associated topic with magnetic field. So people have to be careful when there is a circuit, which does not have a power source, it means it is going to generate power. Electromagnetic induction says you can generate electricity in a magnetic field if you are cutting the field lines. So when you talk about motor is electromagnetism. And when you talk about a generator, you have electromagnetic induction. I do not mention directly the right-hand rule here because that will unnecessarily create some confusion, even though I have posted some videos separately. But remember that the left-hand rule is not used for EM induction. Left-hand rule is used for electromagnetism. So these are the chapters which we have covered today, and I have already advised you people that how you people should be preparing for tomorrow. The biggest memory is needed. The biggest memory is needed for formulas. That's why I asked you people to make a separate formula list, separate formula section. So I'm stopping here, and if any of you have any query, you can ask me now. You can also ask me after the class, even though my reaction time is always a problem because I do not respond immediately because of classes. But if you people have any query right now, you can ask on the mic if there is any confusion. Otherwise, our theory revision is over.
सर मैंने टॉपिकल से पास पर टॉपिकल ही किए हैं, वो इनफ है, और ईयरली भी थोड़े किए हैं, सही है मतलब?
अगर ये तरीका ये है कि देखो, द मेथड इज वेरी सिंपल दैट यू पीपल शुड बी, जो मैंने क्लास के शुरू में कहा था कि आपने अगर टॉपिकल